Have you tried running a Java program in Spark? In the last video, we saw what is Spark, what are the different components of Spark, and what is the architecture of Spark. In this video, we are going to try and create a small Java application and run a Java application inside Spark. In the last video, we opened the Spark shell and we tried something out using the Scala commands, which we saw from the Spark tutorials. However, now we are going to create a small Java program and we are going to try running this jar file as a Spark job and see what all things Spark provide.
Press the bell icon on the YouTube app and never miss any update from Tech Primers.
Let me try creating a new Maven project from my IntelliJ. I'll just go and create a new project. This is just a basic Maven project which doesn't have any other framework as such. I'm going to use the Maven archetype. I'm just selecting Maven project SDK as 1.8. I'll just select this particular option, Maven archetype quick start, which will provide me a basic application which will have just the Maven and Java. And I'm going to give the group ID as com tech primers, let's say Spark, and the artifact ID as Spark Java example. Let's say I'll use the bundled Maven. I'll just give the project name with the space and I'll just say finish. So once I click on finish, this is going to create a small project with all the Maven POM entries which I require to get started. Now the project has successfully imported inside IntelliJ. Let me do an import change. Meanwhile, I want to make it as Java 8 compatible. Let me change that. By default, IntelliJ is giving me Java 7. I'll just say Java 8. Okay. So that we can run it in Java 8. Right. So we have a basic app which has a main. So what I'll do is I'll remove this part. Before we go and start writing our processing logic, we need to add the jar dependency. We need to basically add the Spark API. So I'll be using the Spark API called Spark SQL. So it is nothing but Spark SQL underscore 2.11. So that's the version, that's the artifact ID. The group ID is org Apache Spark. So that is the group ID and the version number of the jar is 2.3.0. So that is the Spark API which I'm going to use because we need to write the Java application in a way which Spark will understand, because it's not like writing any other Java application and just throwing that into the Spark, right? So we cannot write a Spring Boot application and then we cannot use that inside Spark. However, we need to use the Spark APIs and we need to create a Java application. So that's what we are going to do now. So let the import get successful. Yeah, import is successful now. So we need to create something called a session. So since we are using Spark SQL, which we are going to run on the Spark 2 instance, what we are going to do is we are going to create a Spark session. So previously we were creating D streams, and the way we used to do it in Spark 1 is completely different. But in Spark 2, you can use it directly using the Spark session itself. So Spark session comes from the Spark SQL library. So if you see here, the import says org Apache Spark SQL and Spark session. So we need to create a Spark session. This is nothing but like a configuration. So I'll just say new Spark and I need to I need to provide Spark session. I need to do a builder so that I can create a session. I can either do a get or create, right? It will do a get if the session already exists. It will do a create if it doesn't. Meanwhile, I can set some default name. For example, the app name I want to set it as Spark Java example. You can set that. Also, if you want to set the number of executors you want to run, so you can just set the master and you can set the number of threads you want to run. So I'll just say 3 for now. So this is a Spark session. So we have created a Spark session similar to how we create a Spring context. Spark has something called Spark Java context. So Java Spark context. We need to create this context because if you had seen the architecture diagram of Spark, right, or if you see the components of Spark, I'll just show you which I already have. So there is something called a driver. So driver is like a master process which will have something called as a Spark context. And the Spark context is what is going to trigger the worker threads. So these worker threads are nothing but different tasks. So the Spark context will now create an executor with different workers. It could be in the same machine or it could be in a different machine, and these will be executing tasks inside the executor. So basically, Spark splits the processing into multiple machines and it just gives the responsibility to these executors or the workers. They will be finishing the task which was given, and then they will be sending it back to the driver, and driver will aggregate that. So that is how Spark runs all the jobs, right? So and we are going to create this and we are going to try creating an integer stream, and we are going to do just basically streaming of this particular integer stream using the workers in a Spark job. So let's see how we can do that. So we need to create a Spark context. That's when we went there. So we need to create a session, how we saw in the component diagram. We need to create a Java Spark context in order to proceed further with creation of or delegating the tasks to the worker. I'll just do a new Java Spark context, right? And now what I need to do is I need to create some integer stream. So I'll just create an integer stream. Imagine that in a real-time scenario, you might be consuming off from Kafka topic, or you might be consuming it from a flat file. Here I'm going to use a list. So I'll just create a integer list where I'll just provide some different integers. I'll just say 1, 4, 5, 6, 7, right? So I have an integer stream. So basically this is like a stream of integers. So I'm going to do something over it. So that way I will be able to show you guys how Spark can split the tasks and do it in parallel. This is complaining me about something. I'll just enclose it with resources and I'll just move this guy above. And finally, yeah. So once the context is over, we need to stop the context. I'll just say stop. Before that, I wanted to make sure the program runs for a while, and I will be able to show you the Spark UI. So what I will do is I'll increase the timeout to a maximum number so that we can see the UI. So what I have done here is I have created a integer list. Now we are going to iterate this list. Basically, if you are doing it in a normal Java process, we will be doing it in like a stream. We will use the Java 8 streams. However, let's say you are doing it using the Spark features, then we will have to use the context itself. So using the context, there is something called parallelize. So we can parallelize the execution of this streaming process. So we can do a parallelize and provide the integers to that, and you can provide the number of threads you want to parallelize. So basically these are the number of executors you want to do in parallel, right? And if you see, I'll just try saving this into a variable. So this will return something called RDD. So Java RDD is nothing but resilient distributed dataset. This is similar to how you split a stream into smaller chunks, and these operations which we are going to perform will be performed in a RDD. So if let's say we say 3, there is going to be 3 RDDs or multiple RDDs based on the batch size which we have. So in our case we have like almost 10 to 12 integers. These will be split into different RDDs and they will be executed there, right? So that is how Spark does the execution. So that is how Spark is able to quickly render stuff, because individual RTDs has the capability to do to take care of itself. If there is a failure, it will recreate another RTD and execute the same task there. So what can we do with these RTD? So I'll just show you what we can do. We can do a normal for each, but this for each is going to run things in parallel. So what is the argument? So the argument for this is nothing but new void function. We can remove that later. So this is just returning the integer, and I'm just going to print the integer saying Java RTD, and I will just print the integer here. So that way we will know that the control is inside this particular function, right? So that's what we have done. So we use the parallelize concept, created 3 parallel executions, and that returns an RTD. And for each RTD, we are going to just print the integer which came for that particular RTD. So that way we will get to know which RTD received which particular integer. So that is what it is, right? So that's all. So we can run this program directly, but if you run it, it will not run like a Spark instance. It will not run as is, right? What I'm going to do is I'm going to create a package out of it, so that way we can run it as a Spark job. So what do I mean by Spark job? I'll just show you in a minute. So we need to create a package. So I'm doing a clean install. That is going to create a package, and our main class will be app, right? So that is the default app here. The package got created. If you see under the target, the package got created, and if you see, this is the jar. Let me copy the path of the jar for reference. Now let me go to the terminal. I'll just maximize this. So under the terminal, I am under the folder called Spark 2.1.1 bin Hadoop 2.7/bin. See, this is the older version of Spark which I already had downloaded long back. Since I had it already, I'm not re-downloading any latest version. So I'm just going to reuse the same Spark instance because it is already Spark 2, right? Under the bin, you will have lots of files. You can see Beeline. Beeline is a command line for connecting to Spark, or you can even use it for connecting to Hive. Same way, there are lots of other um, command line interfaces. For example, Spark Shell. In the last video, we saw Spark Shell, how to use Spark Shell. Spark Shell. There is a Spark Submit as well. There is a Spark SQL. There are lots of other stuff. So we are going to use Spark Submit in this example. So I'll just say Spark Submit. When I use the Spark Submit, I need to provide some arguments, right? So I'm going to say my class name is of package com tech primers spark.app. This is the class name package, right? That is the class. And you can even pass the threads you want. Since we already passed it, you don't have to, but still I'm just passing it so that we can see how we can override it, right? And finally, we need to give the jar here. So that's all. You just need to say Spark Submit. You need to give the class name and you need to provide the jar. That's all. You don't have to provide anything else. So let's try running this. So this will create a Spark job and this will run now, right? We have given a wait inside, but in general, if you are having a Spark streaming job, it just consumes off from a Kafka topic, or maybe it will take from a file. So if you see here, there is a problem. There is only one Spark context, maybe only one Spark context may be running. Why does it say that? Registering block. Okay. What did we do? So I think we did not even provide the session. Yeah, we created a Spark context, but we did not even provide the session for that particular context, isn't it? Yeah. So what we need to do is we need to use the session dot Spark context, and we need to provide that particular Spark context to the Java context. So we created a session using the Spark session. However, we forgot to pass that to the Java Spark context. That is what we need to do here. I just missed that. Now we need to rebuild the project so that we can reuse it. So once I have rebuilt it, the same jar can be run using this Spark job, and that should be able to use this jar and run the Java code inside the Spark. So the package is created. Let me go to the terminal. Here is the terminal. Let's run the Spark submit command. So this is just going to run the Spark instance with our jar with whatever arguments which we have provided. If you don't want to see the logs from the Spark, you can disable that as well. But I wanted to see what's happening, so I'm just disabling it. If you notice here, it's done. The Spark streaming is done. If you see here, this is the log which we had printed, right? Java, RDD, and all those things. And you can see that there are three executors which got created, which said finish task 0, 1, and 2, right? These are the three executors which we had defined in our code, where we said, okay, use three executors. That's why three were using. Three were created. If you provide more, or if you don't provide anything, you just say star, it will create the number of executors, how many ever it wanted, right? So right now the job is waiting because I want to show the Spark job from the UI. So this is the port number which would have come here in the log in the front. If you see here, wherever we saw, it shows up the the Spark UI. Yeah, see here, right? So created a connection, and it shows up the Spark UI URL here, and that is the URL which I'm using here. So whenever a Spark job is running, you can connect to the job and see what's happening inside the job. See, this is what is happening. We have the Spark job running right now, and we can see what happened inside. In general, if you have a Spark streaming job, you will be consuming messages in batches, so you will be able to see the batches here. But in my case, I just created only one task of streaming a integer and just printing it, right? So that is what this is. If I go to SQL, if you're using a Spark streaming job, then it will show streaming. I have just used the SQL the way we had been creating the session, so that is why I see SQL here. If you're using streaming API, then you can use the stream. You will be able to see the streaming here. And if I go to the executors, this should show three executors which we had been using. See that, right? There are three tasks which got executed as a part of three different executors, right? So that is what this says. And currently, if you see here, the driver is running. You can even take a thread dump here. There are lots of other information like the environment properties which this guy is using. What are the jar dependencies? It also shows the stages of what happened. See this, right? Inside the for each, whatever we did, it shows up the three different tasks which ran and what is the status, how long it took, and stuff like that. Where did it run? So you can even see the executor ID and the host where it ran. In our case, it just ran in my laptop, so I did not have multiple executors. And you can even see some metrics here, right? You can see the metrics around how much time it took, what is the garbage collection, and stuff like that. So this is specific to this particular job. So if you have multiple jobs, every job will have its own URL or the port number where you can connect to that job directly and get information about that particular job. So if you have a streaming job which is just streaming again and again, you can see that. See for here, right? This shows the event timeline. It shows that the jobs are like executing. It shows like fail running. What we can do is we can try making a delay, artificial delay inside the job. So what I'll do is I'll try to introduce a delay here, right? So that way we will know that the jobs are running, because right now if you see, the jobs are getting completed as quickly as possible. So what I will do is I'll just, okay, this is just a consuming message, right? So I'll just do a, after this is printed, I'll just do a thread dot sleep again. So that way I'll introduce some artificial, I'll just do 3000 milliseconds, which is like 3 seconds. Let me rerun this. Meanwhile, I'll just go and kill the job, right? And if I go to the URL, this URL should not, because the Spark job is down. So Spark job is what is like hosting you that particular website. So right now it is down. Let's wait for the package to be rebuilt and then let's try running it. So this what it will do is it will now introduce artificial delays. That way we will know how many batches are running from the UI. We can see what's happening, right? Yeah, the jar got built. Let me run this. So yeah, if you see here, already 3 messages got printed. So that means 3 executors were running, and you can see that, see this, right? This is nothing but green, so which basically means this is running now. So there is one batch which is running right now. I think it should be done. Yeah, there are some things which are running. See, there are 3 different tasks. 2 got completed and the last one is pending, and it shows up what is the status. Now it got succeeded, so the batch got succeeded. So this way you can see what's happening inside the job without even having to configure anything out of the box. So Spark provides these out of the box. Whenever you are running a Spark job, you will get all these as a bonus. If you go to the executors, you can see the executors. If you have a very big cluster inside your firm, right, you can see the number of executors. You can see all those and monitor from this particular Spark UI, right? And this comes out of the box with the Spark API which we are using. And when we are running it from the Spark instance, we can connect to that Spark instance and we can get that particular job specific information. So let me kill it. So I'll just summarize what we did. So we created a small Java application. We added the dependency of Spark SQL. Since we were using the Spark session, we are going to use Spark SQL in order to create a Java application that can be run inside the Spark shell. So we are using the Spark submit to run the Spark job. For the Spark job to be run, we need a jar file, and we are creating a jar file using the Spark API Spark SQL. We created a Spark session. We created a builder. We just named the application Spark Java example. We provided a master with the 3 threads. We said that we'll use only 3 threads or 3 executors basically, or in fact 3 tasks, right? So that's what we did. And we created this Java Spark context, which is nothing but a context decide which will be residing inside the driver, which will decide what all worker threads I need to create and how many I need to create and stuff like that. So that is what we are doing here. We are parallelizing these executions, and we are providing a integer stream to it. That way we will iterate through that particular stream, and we just added a artificial delay so that we can see what's happening, whether the job is showing as running or completed or whatever. So that's what we did. And the RDD is nothing but resilient distributed data stream. That is where our logic of what is there inside this for each runs. So RDD is like, imagine it like a different partition inside the Spark executor, and that is where our tasks run. So the system.out.println ran inside that particular task. So it will be like a different JVM totally. So each executors will be like a different JVM. Then when we had 3 different executors or 3 different jobs which ran right internally, all these 3 will be running in 3 different JVMs. So that is how Spark runs it. So if we are using multiple machines, you can see that these jobs are running in different machines, right? And then finally I was just stopping it. In general you can stop it, but yeah, I was just having a thread.sleep just to show the UI part, right? So this is how you can create a Spark job. I have used the Spark SQL. If you want to use the Spark Streaming API, we can use the Spark Streaming API. I'll try to use Kafka. What I will do is in the next videos, I'll try to create a Kafka topic locally, and I'll try to publish some messages to that Kafka topic, and I'll create a Spark job using Spark 2, which can consume the messages off from the Kafka topic, right? I'll try to do that program, and once it is done successfully, I'll just try to create a video on that, right? Hopefully that will be like a real-time example of how you can use Kafka with the Spark streaming job. I hope you like this particular video. If you have any queries or concerns or any clarifications, do let me know in the comment section below. If you want me to make any video on any specific topic, do mention that as well. If you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.